Okay, good afternoon, everyone. This is Wayne from DJI Agriculture. I'm a solutions engineer. It's a great pleasure to share our views on the topic of drone solutions for precision agricultural. So precision agricultural is a farming concept based on observing, measuring, and responding to field variabilities for the ultimate goal of increasing field yield and also reducing reducing the input. And drone as a spatial technology, it has the full advantage of identifying and also responding to spatial varieties. But that is not the only reason why DJI dedicates to precision agricultural. During the years, we have seen the world starting to adopt drone as a very important farming tool for different reasons. For example, for difficult terrain such as steep slopes, and also to protect human beings from chemical exposure. During this process, we identified that the next global agricultural challenge would be overuse of agrochemical. Oops. Sorry, the pen is not working very well. But yeah, as mentioned, we identified that the next global agricultural challenge is the overuse of agrochemical. Agrochemical, since being invented, it has contributed significantly to global food production. However, overuse of agrochemicals such as fertilizer, pesticide, and herbicide has started to backfire on our agricultural system and also human sustainability. Asian countries, for example, use half of the world's agrochemical, and Americas and Europe follows. But many of these countries have started to release regulations on overuse of agrochemicals. European Union is one of the most ambitious entity. The European Green Deal sets the goal of reduce pesticide by 50% by the year of 2030. And many technology has drawn to contribute to this goal, such as smart tractor with variable rate technology, remote sensing for spatial information collection, IoT on farmland, and so on. And drone as a sky robot, due to its high mobility in scouting and also spraying, has the great potential in practicing precision agricultural. So we would like to introduce you the integrated solution, the drone-based solution for both scouting and spraying. The two solutions that we will introduce today are the tree-mode solution and also the variable rate solution. I will also further introduce the applications on pasture invasive weed control, on tree spraying, and also cropland weed spot spraying. The first one is the tree mode. So tree mode is a solution designed for tree crown targeted and also terrain following spraying. Based on the high resolution imagery captured by a mapping drone, such as a Mavic 3 multispectral drone, the software, Terra, can generate a 3D model of the terrain and further automatically classify the ground objects, such as the tree crown, the obstacles, the water bodies, and pass that information to our spraying drone for targeted spraying. And with the spraying drone targeted only on the tree crown while avoiding all the other obstacles and water bodies, not only the agrochemical usage is saved, but also the environmental and human is being protected from extra agrochemical exposure. So using Southeast Asia country as an example, drone has become a more and more important farming tool for them. During example that we are going to introduce today, has become more and more relying on the drone tree mode solution. So durian is one of the most important fruit production in many Southeast Asia countries, but the spraying for durian tree is not easy at all due to several reasons. The first one is the steep terrain, and also because of its very tall and thick canopy. So many of the spraying on durian trees at the moment is still managed by human beings. It's manual spraying. This is not only not efficient, but it is also not effective, especially when the pest and the disease starts from the top. And furthermore, this also exposes the human operator to great health risk as well. And this is a scenario where the drone solution can really come in to help with the spraying, drone spraying from the top. The disease and also the pests can be stopped where they start. And furthermore, by leveraging the high resolution imagery, let me try to show you. No, not showing, but by leveraging the high resolution imagery and also AI algorithm, the tree crown of the durian trees can be detected and sent over to the spraying drone for tree targeted spraying. So this will save farmers tons of agrochemical usage because all the other areas, such as barren land, water bodies in the orchards, they are not sprayed at all. So many durian farmers in Thailand and other Southeast Asia countries, they have transferred completely from manual spraying or ground spraying to using drone for the full life cycle spraying management. Aaron is a farmer featured in this case study. He started to transfer to drone 2 years ago and have been relying on drone for pesticide, fungicide, and also foliar fertilizer spraying since then. Not only his efficiency has been improved significantly because manual spraying is not something exists anymore. The efficiency of pest control has also been improved while the agrochemical usage is reduced significantly. And similar to durian, a lot of other crops that are common in Europe, such as vineyard, olive trees, citrus trees, they are facing the same difficulty for spraying as durian tree, and drone is a solution that has great potential for helping European farmers in this scenario. Another scenario that could really benefit from drone solution is pasture invasive weed control. So let's use Australia pasture as an example. Invasive weed species such as blackberry lantanas, they jeopardize the pasture's productive capacity by outcompeting all the other native species. And this costs the pasture owners and also the state large fortune to control. The conventional methods for spraying invasive weed species are manual spraying, which is obviously very labor intensive and dangerous for human beings, or helicopter spraying. But the problem with helicopter spraying is it always do blanket spraying of the entire pasture, regardless of the absence and presence of the invasive weeds. But as you can see on the picture here, many of the invasive weed species, they present on the pasture as patches, where spot spraying is very necessary, but that's not something helicopter can do. So the tree mode solution of drone could really help to resolve the problem here. By capturing high resolution imagery of the pasture with our mapping drone, the AI algorithm can detect exactly where the invasive weed patches are and send that information to the spraying drone to do spot spraying. And I'd like to share with you a case study from Australia. In the Gateway Gatwin farm, after transferring from helicopter spraying for invasive weed species to the drone solution, he was able to spray only 153 hectares out of his 300-hectare pasture, which means a chemical reduction of 49%, and that is equivalent to 191 Australia dollars per hectare of saving for the pasture owner, and not even to mention the ecological value here. So that was the tree mold. How about cropland? How about variable rate and precise spraying for cropland? So variable rate technology is a very old concept for cropland, such as variable rate seeding, variable rate fertilization, and so on. But the fact is that the adoption rate of variable rate technology for cropland is still very low of the world, especially outside of Europe and US. One major obstacle of this is the high cost of the investment into variable rate technology, such as soil sampling and testing, and also smart tractors with variable rate solutions. What we are trying to introduce here is a drone-based solution that is feasible, effective, and also more importantly, affordable by farmers. So the drone-based variable rate solution can be broken into 3 major steps: crop scouting, prescription generation, and variable rate spraying. Unlike soil sampling or plant leaves sampling and testing, which is really time-consuming, using a mapping drone to do field scouting can help you to find the crop and also field variability of 100 hectares within 40 minutes. And based on the crop variety of the field, the farmer can generate a prescription map to adjust the application rate for different parts of the field. And that prescription map can then be sent down to a Agras drone for variable rate spraying or spreading, or if you prefer, to do spot spraying. And I'm going to share 2 case studies as examples. One is cotton spraying management, another one is wheat spot spraying. So field variety is very common in cotton fields, either due to soil fertility, irrigation conditions, or so on. But many of these field variability are neglected by farmers during spraying. As I'm showing here in this example, as you can see, this field has very high crop variety. However, when it comes to growth regulator spraying, the farmer just neglect that and do a blanket rate spraying to cover the entire field. The result would be that the area that already has worse growth could be further depressed, and the outcome of that is a lower yield for the farmer at the end of the season. But on the opposite, what he could do is to use a multispectral drone to scout the field in the middle of the season, and then to generate an NDVI map which reflects the field variability, and then do a prescription map for the spraying drone to do variable rate spraying of the growth regulator. That turned out to increase the farmer's field yield by 5%, which is a very promising outcome for this solution. Similarly, the multispectral imagery can also be used to detect the biomass hotspot of the field, which reflects the wheat distribution of the field before planting or after emergence. And by using that information, the farmer could send the spraying drone to do spot spraying. So as shown in the case study here from our partner Planter Drone and Dupritech, a 54% of herbicide was saved by doing spot spraying in this field. And that means a 14.6 euro per hectare saving for the farmer as well. How about pests? How about pest detection and spot spraying? DJI also work with a lot of agricultural AI companies to leverage the mapping drone capability with artificial intelligence algorithm to detect the pest, disease, nutrient deficiency of the plants in the field. Here's a case study from Colorado or from Washington State in United States. So this potato farmer in the season of 2022 adopted this integrated solution by Agras and DJI to detect the hotspot of Colorado beetles in his field and then send the spraying drone to do spot spraying instead of blanket spraying the entire field. So instead of spraying the entire 60-hectare field, only 8 hectares appears to have high infestation level and which really needs the treatment. Okay, so technology is usually adopted by big farmers in the early stage, but please don't forget that about 70 to 80% of the globe's food is actually produced by small to medium scale farmers. And as we mentioned earlier, one very major obstacle for our farmers to adopt precision agricultural technology is the high investment cost. DJI's goal is to make drone a solution for everyone. And so far we have found that not only the drone solution, not only the small-scale farmers can afford the drone solution, but it is also something profitable for them that could help to revitalize the rural population. A lot of our drone users, they use the drone not only on their own farm, but also provide services to their neighbors. So I have an example here from Mexico. Considering all the upfront investment and also the operation cost, the payback cycle for the drone solution is only 92 days. So we are very proud to say that now the drone solution is a technology, it's a solution for every farmer. There's so much more we have not mentioned today that could be benefit from the drone. Corn, wheat, rice, coffee, tea, citrus, and so on. And I believe with you, our partners, we could make the drone solution a profitable and also sustainable technology for the world. That's it. Thank you. Thank you very much, everyone.